Good morning. We were discussing about the reliability aspects for the insulators, in particular to the testing techniques which are followed for ceramic glass and also the polymeric insulators. We have discussed about the various testings which are for the insulators, overhead insulators, classification of various tests that includes the type testing, a sample or acceptance, routine testing and other special tests. So, continuing the same, we have discussed about the importance of the pollution testing, the phenomena of pollution, flashover which happens at the working voltages in the field, how to take proper remedial action, that also we will be discussing. So, continuing with the reliability testing part, we will proceed on to the tests which are being conducted or which are to be done at the laboratory or third party laboratory or at the factory sites. These tests are very important for the extra high voltage levels. So, some we have discussed. Further, the power frequency tests, these tests are carried out at normal operating power frequency 50 or 60 hertz, both dry and wet conditions. So, power frequency tests are classified again based on the outdoor insulation, the withstand levels for dry conditions, that is under normal conditions, and under wet conditions, that includes the rain conditions. So, here the insulators will be tested for the withstand capability and also the flashover breakdown strengths for both the conditions. Next will be the RIV, that is a radio interference voltage test. Why this radio interference voltage measurements is very important. Again, this happens at the higher voltage levels, particularly at 220 kV and above systems, where the radio interference noise initially causes the disturbance in the radio and communication networks. So, the hardware or the radio noise which is generating from the insulators, hardware, conductors have to be within the specified levels as per the prescribed standards. So, followed by is the corona test, corona and again corona visible discharges and both audible noise which are again emitted from the hardware of the accessories, conductors and also the insulator metal fixtures. So, these have to be limited and the noise generated by these which sometimes causes a serious concern has to be limited. So, followed by the power frequency corona is the power frequency voltage distribution test. This is important in particular for the ceramic, porcelain or glass insulator because the distribution of voltage, when you see the insulator string here, you can see number of insulators, again this number of insulator depends upon the voltage levels. So, higher the voltage levels, number of discs employed in the string are also are higher. So, this voltage distribution across these insulators should be made equal with proper arcing horns or corona control rings. So, that the stress near the line end, particularly near the line end, should not be very high. If it is very high, the first insulator or the second insulator will be stressed too much and the flashover could happen or the puncture could happen or the insulator fail. There will be a failure of the insulators and further cascading effect will follow and there will be a flashover of across the entire string. So, to prevent this, proper voltage distribution tests are also carried out in the laboratory. We will discuss about this distribution, how it is being done in the laboratory and the importance of that. That was about the power frequency test at 50 hertz or 60 hertz. Further classification is the impulse test. Again here we have discussed about various impulse levels, that is because impulse are very short duration and these impulse tests, impulse could be observed because of the lightning, natural lightning, where a typical waveform which is described in the standards as 1.2 by 50 is to be impinged on the test sample and the performance of the sample is to be done. So, both for switching and also the lightning purposes. So, again switching is 250 by 2500 microseconds, typical front and tail times. So, these waveforms are impinged on the insulator string or a single disc of insulator, and the performance for withstand and flashover are carried out. So, that this once evaluated in the service, it is to be understood that it will be able to perform. The third is the pollution or a contamination test, which we have already discussed the importance of this, why it is the importance as this happens or the flashover of pollution happens at working voltages. So, that is the reason as per the methods 60507, the pollution testing has to be carried out on the ceramic and glass insulator. Polymer insulator or composite insulator methods are also being formulated, standards are being evolved for the composite insulators. We will be discussing about these aspects on composite insulators for pollution studies. This is a RIV or a corona measuring circuit. This is as per standard IEC standard 437. Here radio interference voltage or corona measurements are to be carried out as per the circuit given here. You have a high voltage transformer here. The high voltage transformer is connected to a low pass filter here. The filter is properly tuned. This low pass filter is connected further with the bus bar, and here the test sample is connected. The test sample again depends upon the insulator or insulator string or any other test object which is to be carried out for radio interference or the corona testing. So, further you have a coupling capacitor, then you have an impedance box which consists of a resistor and inductor, and further the measuring cable or the cable which is being taken from the divider here as shown, and this is going to the radio noise meter. So, all this is the IEC standard circuit which is being specified. So, this has to be followed for the testing of or the evaluation of the insulator strings or hardware in any high voltage lab. So, now we will discuss the importance of each and every component here, the transformer, the filter, the bus bar, and how the coupling capacitor, the importance of coupling capacitor, and the radio noise meter specifications which are to be followed in any internationally recognized testing laboratory for the conduction. So, the high voltage transformer which we have seen, that is very important. So, high voltage transformer must be capable of supplying current which is required by the test object. That you have to know. So, the test object again it could be the hardware, the insulator string could be having number of discs which are connected, and again here the configuration could be a suspension, tension, or a V type of insulator string consisting of several discs as per the field conditions. So, this transformer must be able to supply the current required by the total test object, and the coupling capacitor which is shown here, these two are to be noise free. Both the transformer and the coupling capacitor are to be noise free, because if these give the noise which is generated by the sample could be coupled and the measurement may not be accurate. That is the reason high voltage transformer and the coupling capacitor to be noise free. And the filter which we have discussed, that is a low pass filter which is connected here. The main function of this is to limit the noise which is being transmitted to the measuring circuit. So, the filter which is connected near the transformer, so has two important functions. It prevents the noise from the transformer to the test object, and also the noise generated from this side also is being prevented. So, the RIV measurements are generally recommended to be conducted at 0.5 megahertz to 2.5 megahertz. This is the standard specifications, and as per the utilities, the manufacturers, the value will be decided where the measurements have to be carried out. So, the high voltage transformer must have a capacitance up to hundreds of PF. If filter was not absent, some of the noise as mentioned from the test objects will flow to the transformer. So, filter mainly avoids this. So, low pass filter has importance in capable of being tuned to resonance at frequency of measurement, and also it avoids the noise generated from the sample or from the transformer side. High voltage conductors or the bus which is shown here, this should be a smooth conductor, and also it should be terminated properly at the ends, in particular at the end junctions, say ends, that is the reason we have highlighted here the terminals ends. It should be properly terminated, so that the corona or the discharges from the edges should not be transmitted to the measuring circuit and to the measuring meter. As mentioned, coupling capacitor, this again should which is shown here, the coupling capacitor. Presently in the laboratory we use 1500 PF, or when 765 kV string is being used, it will be a different value. So, this again should have a capacitance, a minimum of 1000 PF, which is approximately 5 to 6 times of the test object. So, apart from presenting, we know that coupling capacitor, apart from presenting low impedance particularly to high frequency noise currents, it has to present high impedance at power frequency or the working voltage levels. So, the noise signals which are generated at higher frequency should be able to pass through this, and it should be communicated to the meter. The measuring impedance has shown, it again is the standard value which is to be used, or the standard specifies the measuring should be carried out by across the 300 ohms. And also the standard mentions that in case of a 300 ohm measuring impedance is not available, resistance is not available, it could be carried out by using a 30 ohms to 300 ohms. Later on the values are suitably made equivalent to 300 ohms with the suitable correction factor which is to be added for all the values measured at that across a particular value resistance. So, the final important is the meter which is being used, again a radio noise meter. This is again a very important aspect where it has to be followed as per the standards. So, radio noise meter should be as per the CISPR standards, ASPR standard. This is meter, it could be a selective microvolt meter where it should be able to measure at a frequency range depending upon the requirement. So, in the laboratory we have radio noise meter which is of a model SMV11 and can measure from 9 kilohertz to 30 megahertz. So, this frequency radio noise meter can be used for sinusoidal radio frequency voltages and measurement of pulse type interference voltages also. And this has a selective measurement range of minus 20 decibel dB microvolts to plus 125 dB microvolts, and you can measure as per the standard specifications, and also has an option of 3 radio frequency bandwidths, and also has several measuring outputs, particularly the modes of indication like the peak value, the quasi peak value, root mean square value, RMS value, and also the average value is able to be measured by using this measurement. So, any laboratory should possess the requirements as per the laid standards of the CISPR measuring circuits and CISPR measuring devices. That was about the RIV. And the corona aspect, I can mention here the same circuit could be used for the measurement of corona or a visible discharge, where the measurement only RIV meter will not be used. Here the entire laboratory will be darkened, the voltage will be applied and raised in steps till the visible discharges are noticed on the insulator string or a metal end fittings or the corona control rings which form the test objects. So, this voltage where it is possible to see the discharges is known as the inception voltages or corona inception voltage, and the voltage level is reduced till the discharges vanish. So, that point is known as the corona extinction voltage. So, inception and extinction of corona or the visible discharges is also measured by using the same circuit. Further, we discussed about the importance of voltage distribution. Here the voltage distribution across the insulator string, this again pertains to the ceramic or the glass insulator, where number of discs in series are connected, and again it could be suspension or the tension arrangements or the V suspension arrangements, it could be twin, it could be quadruple. So, several configurations depending upon the requirement in the field. So, this voltage distribution similar arrangement will be made in the laboratory, and the power frequency voltage which appears across each disc insulator is to be measured. Typically a small spear gap can be used for measuring this arrangement. Here this spear gap could be of 2 centimeter in diameter and with 4 mm gaps spacing. So, this spear gap of known diameter and spacing is used, and this is connected across each disc from the line end. The insulator string as per the defined configuration. So, each insulator is connected with the spear gap and the measurements are carried out. So, the breakdown voltages or the spark core voltages of this spear gap are recorded, and this procedure is repeated for each disc in the insulator string. And the percentage ratio or the average mean voltage that appears across the individual unit is say N. The voltage which is calculated as Vs is the nominal spark core voltage of the spear gap under laboratory conditions, divided by En. En is the mean voltage across the insulator string with spear gap connected across. So, the Vs is the normal, that is just the breakdown of the gap without the insulator string by the breakdown voltage with the insulator string into the 100 will give you the percentage voltage distributed across that particular disc which we are measuring. So, this is a typical arrangements for various configuration for measurements of voltage distribution. This is a suspension insulator string. This is for both RIV and corona. You have a transformer, the filter is here, from the filter it is connected to the test object, then the coupling capacitor it is through the cable, it is connected to the RIV meter. So, this arrangement is again for the RIV measurements for a V type of suspension string. So, for the voltage distribution, the coupling capacitor will not be in the circuit. So, the voltage will be and filter will not be in the circuit. So, voltage distribution without the filter directly it will be connected from the transformer to the sample, and other side of the sample is grounded here. So, the voltage distribution across each disc is being measured and the value is obtained for various configuration. So, this is again a double V suspension arrangement and double tension arrangement. So, this is the typical spear gap small arrangement which is of 2 centimeter dia, and this gap distance again as per the standards it could be 4 millimeters and connected across each disc and the measurements are carried out. That was about the RIV and corona. Now the importance or testing for the insulators, in one of the reason for the failure in the field is because of the steep fronted voltages which an insulator absorb. So, this steep fronted voltages are very sharp rise and fall where the waveform you see here. So, this sharp rising pulses and decaying can puncture the disc insulators. A similar type of waveform which is very which is to be applied to the disc insulator, and the failures of this or a steep front waves which are impinged on the insulator surface and evaluated. This test once it is carried out with the steep front, this should normally not puncture. So, external flashover could happen, but the puncture should not happen. Though typically puncture because of the shell here, a small gap, and you have a metal fittings, you have a cement portion here. Most of the time because of strip fronted samples, the puncture were observed here. So, this should not happen in the laboratory testing. And typical waveform as per the standard, which specifies a wave of 2500 kilovolts per microseconds, that is for both, there is a positive polarity and the negative polarity. So, both these waveforms of polarities with 2500 kilovolts per microsecond is applied to the insulator or insulator string, and appropriately the withstand values for this strip fronted waves are observed. The next is the fatigue test. This is a mechanical test which is done for the site severe conditions with the insulator and also the accessories which are connected to see that the fatigue stress due to vibration are withstood by the arrangement. So, vibrations again could be due to the alien vibrations or because of the natural earthquakes or because of the ice and wind induced conditions where the conductor vibrates or conductor oscillates. So, for such conditions this experimentation or the test is conducted and it is being carried out. Here the normal testing is carried out with complete hardware which is erected with appropriate span as shown. A typical example is shown here with predetermined frequency and amplitude as per the standards, and it is vibrated for a known period of time. So, the span is given and the vibration frequency is defined and with all the necessary arrangements as per the field conditions, and it is made to oscillate for a known period of time and its performance is monitored. The one of the important testing for insulators is the power arc testing, which several of the over voltages occur which results in flashover across the insulator string. So, this power arc is a very important testing which again simulates the conditions in the field. So, here the power follow current which succeeds the flashover after the flashover, this could reach dangerous limits especially in the event of malfunctioning or delayed tripping of the breakers. So, in case the breakers do not operate, then the follow current or the power follow current which we call immediately after the flashover, this will is very dangerous and could destroy the equipment. So, the high currents during such power arcs cause enormous heating and also consequent damage to the tower, line hardware, conductors, insulators and other electrical equipment which are connected in the network. So, typical circuit for the power arc test is given here. You have one side a short circuit generator with the circuit breakers and the controllers. On the other side you have a transformer which is of known ratio, and you have a test specimen. So, this power arc testing, the samples are being impinged with kVA rating as per the field conditions, and few cycles of that is applied and the performance of this is monitored as per the standards. So, these are few of the examples which failures have happened because of various conditions in the laboratory in the field. Similar simulations are necessary to be done in the laboratory conditions. So, this we have discussed lightning impulse and switching impulse. Again, this is one of the important type tests which are carried out to see the insulators perform particularly or withstand the basic insulation level which it is designed and is dependent on arcing or striking and distances. So, very important lightning impulse waveform has been already told, again I am repeating here. This waveform is typically a double exponential waveform with a front time of 1.2 microsecond and a tail time of 50 microsecond till here. Similarly, this is a switching waveform full wave with the 250 the front time, TF is the front time, and the tail time is 2500 microseconds. So, this impulses, again the standard specify the number of impulses both positive and negative, could be 5, 10, 15, again it depends on the manufacturer and the utility agreement, where number of impulses are impinged on the test object and the performance of the insulation level is monitored. This is one of the important testing which is normally carried out on the insulator string. Here the power frequency withstand and flashover. So, the insulator string, which consists of number of discs, are to be applied a voltage, and this voltage which is the normal voltage, and taking into the consideration of the over voltages, whether the string withstands the particular voltage or the failure of the string happens, this has to be done in the laboratory. So, appropriate voltages for a known value is applied to the string, and both withstand and the flashover of the insulator string. So, this again the manufacturer and the utilities decide about the disc type, the flashover and the withstand voltages have to be carried out either for single disc or for the number of discs in a string, and this testing is very important to ensure that the withstand or a flashover does not, in case happens, it has to be able to withstand the over voltage surges, and the insulator string should be able to. So, these are the summary of all the testings for the ceramic or glass insulators. So, various important type tests, in fact important testings like T is for type test, A is for acceptance, R is for routine test has been mentioned here. So, you can see various type tests being it could be the visual examinations, this comes under both the type test and the routine tests. So, similarly verification of dimensions, it is a type test, impulse withstand, visible discharge or a corona, wet withstand, temperature cycle test, again mechanical test, puncture test, these come under both tests, that is type test and acceptance test. Similarly, the porosity test, this is for the material of the ceramic disc, here to find out whether there exists any air bubbles inside the ceramic shell. So, this again comes under 3 categories, that is the type test, acceptance and the routine type testing. So, after this you have the galvanizing testing, which is normally carried out in the factory, that is as per the acceptance test, and also the third party certification which is mentioned as the type test. So, you have thermal mechanical, then you have vibration, these are all the mechanical related tests. We have also discussed about the radio interference test, pollution test. So, several of these things again depending upon the voltage levels which the insulators or insulator string is being used, the tests are specified in the standards 60060 IEC, which are mandatory before it is being used in the field. So, that was about the importance of the ceramic or the glass insulators and various type tests which are to be carried out. So, these type tests to be carried out for the composite insulators. So, composite insulators or silicon rubber or polymer insulator, as mentioned, these are of recent origin, and these tests are entirely different from the ceramic or glass. Few of the tests are common like power frequency, impulse test, but unmechanical testing. There are several tests which are to be developed, or it has not been standardized in particular to the HVDC applications of composite insulators. So, the reliability and testing in reference to the composite or the polymer or silicon rubber insulator assumes prime importance, where the stringing of the insulators in the field has to be properly seen that whether the insulator string will withstand for the stresses, various level of stresses. So, several of the tests are being conducted in the laboratory, some are standardized and some are yet to be standardized. So, we will focus into these aspects and we will discuss about the importance or tests which are being carried out and why it is important in case of the ceramic in case of composite, why the similar tests cannot be carried out. The first reason being the composite insulators or polymer insulators, these are of recent origin and organic in nature. So, that I am stressing the point here. So, these insulators have metal end fittings with a fiberglass rod and a silicon rubber which is molded and pressed on the fiberglass rod. So, these insulators are also being used for HVDC lines and many of the high voltage DC lines are planned and being executed in the country. So, with increased demand necessity of the insulators, particularly the composite insulators which have better features than the ceramic or glass, which have more aesthetic, more light in weight, more performance. So, that is the reason many utilities not only in the country, abroad are trying it out for the higher voltage with the composite insulators. And in particular the phenomena or a contamination phenomena or a pollution flashover phenomena, which is very important phenomena while designing the line insulation for AC, is also equally or more severe in case of DC. So, this has also been observed by the field conditions and the data which is collected by the utilities and the manufacturers. So, this shows that the composite insulators perform better in case of the severe polluted conditions. That is one of the major advantages in being using this. So, with increased use of this composite or polymer or silicon rubber insulators, there are problems because of organic material which is used for the sheds. This over the period or because of aging, the problems like the tracking and surface erosion, that is the peeling of the surface or the puncture of the surface or degradation on the surface happens over a period of time. So, this is a serious concern particularly to the utilities who use the composite or polymer insulators. So, this is the reason where new dimensions are added to the area of performance of the composite outdoor insulation. So, being organic as mentioned, that is a polymer or a composite insulator, they suffer degradation. So, degradation again, why degradation, what is the degradation, we will discuss further. This again is due to degradation can happen on the surface due to the electrical stress and also the environmental stress which is facing in the field. So, lot of research activity, significant research has already been carried out, lot of work has been initiated, several standardized procedures are being come up and there are still activity where several international groups are focusing for the better improvmental aspects and also suggesting the standards for the composite or polymer insulators to tackle these problems related to the degradation, aging aspects. So, apart from the literature, some of the standard, that is the international standard reference 62217 which gives IEC, which is gives the polymeric insulators which are used to be outdoor or indoor applications with a nominal voltage more than 1 kilovolts. This clearly gives various procedures, methods and testings to be carried out for the polymer or a composite insulators before they are being used in the field conditions. So, similarly again further there is a technical report which is from the IEC 62730. This again gives the important information about the high voltage polymeric insulators both for indoor and outdoors and stresses the importance of tracking and erosion particularly by rotating wheel test for a period of 5000 hour test, how the testing has to be carried out, the importance of various aging testing aspects. So, these are some of the standards which there are other standards for each testing in general. These are to be also of importance. The recommended applications for the composite or polymer insulators, you can see here several testings as per the standards are available. Apart from that the testings for composite, this is you can see here the design test for polymer insulators has for outdoor and also for indoor. You have composite polymer insulators, here you have resin based insulators. So, for both which are the tests required has been given in this table. So, pre-stressing of the materials it is required, then water emulsion testing has to be carried out for all the materials except for the indoor resin it is not required. Verification test, visual examination is very important. Then steep front like ceramic or a glass, the steep front plays a major role even in for the polymer or a composite insulator. So, this has to be tested for both the indoor and outdoor application. Then power frequency as mentioned earlier, power frequency is a test which has to be carried out at 50 or 60 hertz for the withstand and also the flashover arrangements. You have a hardness test, this is mainly for the rubber. So, it has to be done for the outdoor insulation particularly, and for indoor it is not essential. Accelerated weathering test on this again the rubber sheds, this is required for the outdoor insulators. Tracking erosion, what is the tracking, what is the erosion, how it happens and what are the tests which are to be carried out. We will be discussing about the methods when we are discussing about the methods of the tracking and erosion. Flammability to check whether the rubber insulators will be able to withstand the flammable testings when it is done. So, again dye penetration, this is mainly required for outdoor insulation, and water diffusion test. So, this is all these are specified in the standards recommended as per the IEC 62217 here. Apart from this there are standards which are being evolved for long duration or the aging of the polymer insulators has not much of activity or not much of data, because these insulators are being used recently for last decade or two. So, a lot of information about the aging is not yet available. So, standards are yet to be evolved for both some for AC and some for DC. Several points have to be looked into and the standards have to be evolved. So, some important properties particularly for evaluation of a polymer or a composite insulator. So, Seagrave working group, this is the group which looks into the high voltage aspects on the polymer or a composite insulator. The working group D114 is focusing on the importance of several properties, and they have recommended some of the standards to be followed for the evaluation and testing of these insulators. So, Seagrave is again the International Council for Large Electric Systems, which is a body which decides about the standardization of the testing, suggesting several methods which to be followed. So, here this group has come up with 12 important parameters recently. So, 12 important parameters again consist of resistance to tracking and erosion. Here the reference to 60587 standard can be made and the testing of the material can be carried out. Then resistance to corona and ozone. So, these rubber insulators which are in the field are prone to the effect of both corona. Corona could be because of the hardware from the insulators, strings which are connected, could be corona control rings or the metal parts. The corona which is impinging on the rubber surface over a period of time could cause a serious issue in case the water seeps in, forming the nitric acid and also the effect of ozone. So, for this the standard has yet to be evolved. So, that is the reason it is mentioned here, it is the standard is under consideration. Lot of activity, lot of experimentation, lot of research work is being progress in this direction. Several publications are also coming up. So, the standardization could happen wherein the resistance to corona and ozone could also be done. So, resistance to chemical and physical degradation, how this happens, there is a standard which refers 62217. So, which is known as water diffusion test, has been recommended by the standards. Similarly, mechanical aspect, tear strength, there is a reference standard, volume resistivity, breakdown strength, resistance to chemical attacks are all been given in the respective standards. The procedures are laid down and the insulator or insulator string is being tested to this. Resistance to weathering and UV, this is the climatic conditions, that is a multi-stress arrangement in the field in case of various pollution condition, rain conditions, fog, ice loading, several of these things, the effect of these weathering and the effect of UV on the sample, the ultraviolet radiations which are from the sun and also from the corona of the hardware, the corona caused UV radiations. So, effect of these things are not yet fully available. So, the standard is yet to be done. Similarly, resistance to flammability, this again is also under consideration. You have arc resistance, glass transition temperature, again these are standards are available, how the experimentation has to be carried out in the laboratory and the third party certification laboratories. The final 12th point by the CGRE working group focuses on the hydrophobicity stability transfer. So, this is a very important aspects, because the sheds or the silicon rubber material should be hydrophobic in nature. So, the water repellent activity. So, once the water repellent activity loses, then the surface becomes wet and it will start absorbing the water moisture, the pollution, and the insulation level could come down. So, for this, how the classification of this, how the stability transfer, for this there is the standard still under consideration. So, these are the important 12 parameters which are being considered by the CGRE working group for the standardization. Some of them have evolved, some standards are yet to be evolved. So, we have looked into some of the regular testings carried out for various insulators, some important testings for the composite insulators. So, all these require proper evaluation and testing which are as per the available standards, and because these insulators are of very recent origin, there are some standards to be evolved. So, lot of activity is still necessary, in particular to sometimes for both or sometimes to DC applications where standards are not yet fully available. So, corona studies in particular for both AC and DC, lot of information is still required. People are working on this effects on the composite insulator samples and trying to understand the phenomena and the effect on the insulators. The second point is evaluating the tracking resistance and erosion. This is again over a period of time, even though there are standards which are being prescribed, here again for DC application it has to be evaluated. Low current arc discharges, these are the standards 61621 is specified in case the continuous low current arcs which may be predominant on the surface, whether the surface becomes hydrophilic after some time. So, this has the standardized procedure for conducting. Inclined plane testing method which is being suggested, there is a standard for this. So, here again for AC the standard procedure is available, for DC it is yet to be standardized. Similarly, accelerated aging facility, this is the long term performance of the polymer or a composite insulators. Here the accelerated in the sense we apply a slightly higher voltage and higher parametric like the standard specifications, and see that whether this will be able to withstand over a period of time. Here again both for AC and DC, in particular for DC still the standard for accelerated aging has to be evaluated or it is necessary. So, tracking wheel arrangement standards are available for AC, DC it is not yet standardized. Facility for conducting multiple stresses you have a standard for AC, so DC has to be done. So, several of these experimental testings which are recommended by the standards, and some are yet to be evolved for the DC application. So, it was felt necessary some experimentation towards both AC and DC on the samples as well as the insulators were carried out in the laboratory to verify and understand the phenomena which could cause serious degradation or surface hydrophobicity loss, and we will discuss about some of the experiments which are being carried out. The first one being to evaluate the performance of the silicon rubber insulators in case if it is subjected to environmental and corona. This is very important. So, the equipment or the facility is been developed to simulate the conditions, both environmental like the fog conditions, it could be a normal mist which is being continuously on the silicon rubber surface, and the continuous corona is impressed on the sample. So, what could happen again here to simulate these conditions, the corona needles are properly designed and this corona is generated and it is impinged on the sample simultaneously with the combined effect of the environmental conditions. So, for both to understand the corona phenomena on polymer insulators for both AC and DC transmission, a laboratory experimental facility is being developed and experimentation has been conducted to study the degradation phenomena on silicon rubber using the developed methodology. So, here you can see the importance of corona. Corona, as I mentioned earlier, corona is seen on the conductors in case the surface is not designed, in case the surface is not smooth and the conductor is not designed as per the required voltage levels. Second is the corona control rings. The corona control rings, if not properly designed or not properly placed, this could lead to the corona. Here you can see the corona control rings, the corona which is coming out, insulator strings are here, a vertical double eye suspension. This corona which is generating from the corona control rings is impinging on the silicon rubber insulators. This has a continuous effect in the field as the insulators are energized continuously, the conductors are energized continuously, and the discharges which hit the insulator surface over a period of time, there could be a surface damage or the moisture, the pollution and other contaminants could again see that the surface of the silicon rubber becomes hydrophilic and thereby the water seeps inside the silicon rubber sample and the fiberglass rod may get brittle fracture. So, this is the importance of corona. How do we simulate in the laboratory has been done on the samples. So, this is again one more typical example of the droplets because of the rain on the conductor. So, the corona could be a droplet corona, water droplet which hangs on the high voltage conductor during the rainy conditions. So, you see here these are the metallic ends, you have a silicon rubber, in between you have a fiberglass rod. In case the surface of the silicon rubber is completely degraded because of the corona impingement, the damage could happen and the fiberglass rod which is present after receiving the moisture and the contaminants and because of the corona impingement could see a nitric acid which be formed, and this nitric acid could damage the structure of this brittle fracture of this rod could become brittle over a period of time, and in case particularly near the ends here, junction of the metallic ends, during the crimping, if the microstructures are present, the crimping, this again will definitely lead to the brittle fracture of this insulator, and detachment from the line end could happen. So, for corona studies in the laboratory for both AC and DC composite insulators, so facility has been developed wherein various electrode arrangement, this is the electrode arrangement, this is a sample holder, a proper sample holder, and the samples of different sizes, it could be 2 millimeter thick or 6 millimeter thick samples of unknown dimensions are used, and they are fixed to the sample holder which is of this nature, and the experiments are conducted by applying AC or DC with control conditions, with dry conditions, or with effect of acidic conditions, and so on. So, this is a typical arrangement which has been developed in the laboratory. You can see here the corona control corona cage, that is a perspex chamber has been made, wherein you have an electrode assembly here, the sample is mounted here with a sample mounting arrangement, and the bottom side is grounded, and the high voltage is connected from a source of HVAC or HVDC source. We have both HVAC and HVDC source, and you have a control panel where you can apply a suitable voltage depending upon the gap distance here, and the choosing of this is being done. So, you have a small generator which is called as a fog generator. This generator will have a small pump here. From the pump, this is again dry air as well as the fog is being pumped into the chamber, where it has 2 inlet and 1 outlet valves. So, this arrangement is being made to simulate the environmental conditions. So, the moisture, mist or the acidic fog is simulated on the sample, simultaneously the voltage is applied, the voltage is either AC or DC. This corona which is generated by AC or DC again consists of the electrode arrangement of this nature. You have simulation by using various needle structure of this type, where a uniform corona can be impinged on the test samples. For non-uniform, you use this type of needle arrangements where you simulate the non-uniform corona. So, this impingement on the sample over a period of time, planned period of time, is continuously stressed with a planned cycle for moisture or for the fog, and the samples are evaluated. Samples can be of 2 mm thick or 6 mm thick. These samples are evaluated after the experimentation. So, surface morphological changes which are seen on the rubber samples are carried out for chemical analysis, and the surface changes which have happened are done. So, various experimental at different voltage levels are shown here. Typically, this phenomena, which is a corona which is generated by the uniform electrode here, both the cases, here it is again a uniform electrodes with this is again with a comb electrode, different for non-uniform conditions, this is for uniform conditions. Here without fog, that is no mist, fog is applied, you can see the spread of plasma of the corona which is from the needles on the samples here. When the fog is applied, you can see the spread of plasma is only leader type of where you can see only the discharge happen from the point to the point here, the spread is reduced and the intensity could be higher once you apply the fog. So, this again for non uniform conditions, you have the phenomena which has been shown here. This phenomena is generally not will be able to see with the naked eye. So, you have to have a better exposure for capturing these images. So, wherein we have used a normal DLSR camera with a 30 seconds exposure time, wherein you can try to see the phenomena, understand the phenomena, how it impinges on the sample, and try to evaluate the sample over a period of time. So, as mentioned, we have seen the corona phenomena which is impinged on the sample. So, later on to find out the performance of this rubber sample, so several surface morphological studies have to be carried out. This surface morphological studies will give you the analysis on the samples which are used for experimentation. This gives an idea of the rubber insulator which is being used, the performance of that for the impingement of corona. Here again you have FTIR measurements, which is known as a Fourier transform infrared spectroscopy. By using this, the importance of the information you get will also be seen, why the FTIR is being carried out. Similarly, X-ray photoelectron spectroscopy is being used to analyze and interpret the results. Scanning electron microscopy, thermogravimetric analysis, TG analysis, wettability class measurement, this is again hydrophobicity measurements. Apart from this, electrical measurements like leakage current measurements are also being carried out during the experimental period to give an idea the leakage current which could analyze, or the leakage current data can be analyzed and interpreted to see that the degradation or the corona phenomena over a period of time. So, why importance of spectroscopy, that is a Fourier transform infrared spectroscopy. Here important is the transmittance spectra peaks which correspond to 1008 show that in case if the peaks reduce, this confirms the loss of main chain bonds which could result in depolymerization leading to the material properties, that is the surface conditions changes, it becomes, the material becomes depolymerized. Similarly, in the range of 3200 to 3700 in the spectrum, that is a transmission spectrum, confirms in case the peak reduction is observed, this confirms the loss of ATH fillers and the aluminum trihydrate fillers which are used in the making of the material along with the silicon rubber. So, these fillers if the loss is observed, then the surface could be degraded over a period of time. Then SEM and IDAX. So, SEM is again scanning electron microscope which is normally carried out to represent the surface morphological studies. This shows the surface roughness and also the formation of cracks in case if it happens over a period because of the corona hitting on the samples. So, IDAX, electron dispersive analysis, this gives X-ray analysis gives the results, show the changes in elemental presence over the surface resulting due to the effect of aging of corona. So, X-ray photoelectron spectroscopy, which is known as XPS, this also is a proven method which is used for accurate quantification of the elemental composition from the other two methods. So, TGA or thermogravimetric analysis, this is performed mainly to examine the changes in the chemical composition or changes in the surface conditions. So, that this TGA analysis presents bulk information, particularly it represents loss of aluminum trihydrate fillers which are added to PDMS. PDMS is polydimethyl siloxane. This is the material used for the insulators. So, this PDMS added with aluminum trihydrate fillers form the compound which is being used for the manufacture of silicon rubber. So, here these fillers which are added enhance the electrical properties. So, the loss of aluminum trihydrate will further accelerate the thermal degradation. So, this analysis gives an important information about the filler aspects where loss of filler aspects. So, the other is the wettability measurement, again wettability or hydrophobicity measurement what it is known. So, hydrophobicity measurements performed on the samples, it could be on the slabs or it could be on the full scale samples. This is carried out as per the IEC 62073, and there are methods for both. For the flat samples, a droplet of water is put on the sample, and using a goniometer you see the sample hydrophobicity characteristics. Depending upon the water bubble and hydrophobicity nature, it is classified as hydrophilic and which stage, so on. So, similarly for full insulator, there is a method which is as per the standards, which shows a fine spray at a known distance to the insulator, and the insulator is kept at an angle, and the water is sprayed, so known quantity of solution is sprayed with a certain pressure, and the measurements are carried out. So, this wettability measurements will also give you the idea of the hydrophobicity characteristics of the silicon rubber after the testing or after the evaluation of the samples. So, these are some of the examples which we have already discussed, that is the Fourier transform infrared spectroscopy. So, this gives the transmittance along the y axis and the wave number along the x axis as mentioned earlier. So, this 1500 to this information, so 1350 to 1500 gives you the peak which was discussed, and also 3500 to 3700. So, here this gives the very information about the loss of material in case if it is near the 1000, confirms loss of bonding or depolymerization, which leads to loss of material properties. In case of 3200, it confirms the loss of ATH fillers. So, this gives an indication of that in the FTIR spectroscopy. So, further XPS photoelectron spectroscopy gives the elemental which has been of importance. It shows the quantification of the elemental composition. So, this is also a very important information. Scanning electron microscopy, here scanning electron microscopy gives the surface conditions or a surface information after the experimentation, and also the formation of any cracks or the breakage of the bonding on the surface. So, this could lead over a period of time wherein the moisture or the pollutants could collect and the surface degradation could happen. So, this SM gives the information. This is the contact angle measurement information, where you can see that the standard contact angle up to 100 degrees has been carried out on various samples at different timings. So, wherein the information about the hydrophobicity characteristics can be known. Some observations pertaining to the corona experimentation in particular. So, we have seen corona in the presence of moisture on the insulator surface will induce more hydroxylation on the polymer surface. The effect of polymer degradation induced by the AC corona is much more in comparison with the DC corona. This is the experimentation which has been carried out in the laboratory, found that AC corona is more in comparison with the DC corona, and experimentation with the moisture, it is found that formation of acidic species, particularly nitric acid on the sample surface was noticed with the treatment when with mist or a fog condition was carried out. Some of the cases it was observed the surface rupture or surface damage was observed for the fog treated, that is a mist or the moisture treated samples wherein the surface was degraded. So, this similar phenomena could happen in the field wherein the surface gets degraded. So, degradation studies further, that was about the corona aspects. Further degradation studies on composite insulators have been carried out as per the standards, and also lot of experimentation investigations are being done to find out the surface erosion, particularly at low voltages, and also the tracking and erosion studies which are carried out using the inclined plane method for both AC and DC. So, these experiments have been carried out and evaluated for the various insulators and also the materials. The second is the long duration important long term aging studies on full scale polymer insulators. So, this gives an idea of the samples which could last for a certain period in the field. So, both methods have been followed. One is rotating wheel arrangement, where this facility was developed for this experimentation. The second is a multi-stress aging facility. The multi-stress aging typically is a standardized procedure. In the laboratory it is equally difficult to simulate all the conditions. The process of simulating as per the standards is in progress, but preliminary experimentation on the multi-stress aging has been carried out in the laboratory using the 4 parameters. So, as per the standards it is 6 parameters. Presently we have tried to carry out and understand the phenomena with the thermal, ultraviolet, fog and electrical stress, and here we have tried to understand this aging of the samples thermally, both for normal conditions and also for very low temperature conditions. So, here this low temperature sometimes is also affects the samples. So, this also has been studied and evaluated. So, this is the standard method as per the 6011 standard, wherein you have the electrodes here which are kept, the sample is here, the test specimen, and you have a dropping device. The droplets are dropped continuously, the voltage is applied and other is grounded. So, here the specimen is tested for a known droplets, and during the droplet there is a arc which is noticed here. The sample, the degradation of the sample and the surface conditions could be monitored by using this comparative tracking index. This is one of the experimental arrangement as per the standards. The second is the evaluating resistance for high voltage low current arc discharges. This facility has also been developed to study this effect, wherein the high temperature vulcanized silicon rubber samples and also the liquid silicon rubber samples were experimented in the laboratory. As per the standard procedure, the electrolyte of 0.1% sodium chloride with resistivity of 4 ohm meter specified has been done. Electrodes, gold coated copper electrodes were used, and the sample size was typically 25 mm by 25 mm, a thickness of 6 mm. And droplet size, we have a dropper here, a droplet size of 20 mm square as per the standard, and a flow rate 1 drop per 30 seconds. The drop on the sample, 1 drop per 30 seconds was done, and number of drops, again this standard specifies the values. We have gone and studied the effect for various conditions depending how the number of droplets increases, how the degradation happens for various voltage 250, 500 and 600 volts. So, experiments were conducted and samples were evaluated, various samples were evaluated, both high temperature vulcanized silicon rubber and also the liquid silicon rubber sample. This is the erosion formation which has happened for a typical sample. During the experimentation it was observed that no sample punctured or failed, but samples were eroded as seen here, and also the SEM studies indicated the erosion particularly near the droplet fall and adjacent to the electrodes. And Fourier transform infrared spectroscopy shows a severe depolymerization near on the surface, and also the loss of hydrophobicity here, because the surface gets degraded and it starts collecting the water droplets. So, hydrophobicity characters also, and further this could lead to the erosion and degradation of the material. This experimentation is as per the IEC 50587, that is a 60587, which is internationally recognized, or known as the inclined plane arrangement method. You have one electrode, top electrode, a bottom electrode. This arrangement, the color blue color light green color indicates the sample which is fixed here. So, you have a series resistors to control, you have a high voltage, and this is the arrangement which has been done. So, the sample sees the high voltage and the ground here. So, continuous water as a solution is being pumped through a constant rate using the peristaltic pump. So, this again as per the standards we use the peristaltic pump, wherein the discharge wherein the solution is is dropped here and the voltage is continuously applied for a known period of time and a known voltage is applied both for AC and DC. Several experiments have been conducted and the evaluation resistance of tracking and erosion have been done in the laboratory both for AC and DC applications. So, evaluating resistances for tracking and erosion, you can see here inclined plane arrangement has been developed. This is the electrodes sample here and you have a electrode arrangement here which has been done. The voltage source, you have an oscilloscope, the peristaltic pump, the resistors as per the standard, and this is the arrangement for the inclined plane testing. So, this is for AC, this is for the DC arrangement. So, you have left is the inclined plane arrangement for the AC source of 50 kilovolts with a peristaltic pump and an arrangement. You have a DC source 10 kV with an arrangement. So, both the experimentations have been carried out on several samples of each type and the performance is evaluated. Further, during the process of the experimentation, the hot spots which are formed or the temperature profile is also being monitored using a thermal imager wherein to accurately pinpoint and see the degradation of the surfaces near the electrodes and how the propagation of the arc happens. So, all these things have been studied in detail and the performance has been monitored. During the experimentation, leakage current also has been monitored over the period of time at various voltages 3.5, 4.5 kV etc., both for AC and DC applications. So, leakage currents were measured and with the help of the leakage current try to interpret the data leakage current data for the erosion or the surface changes which are happened during the experimental during the experimentation. You can see that how the surface degrades over the period of time during the experimentation wherein the surface erodes and the entire surface becomes sample becomes punctured. So, this happens again depending upon the solution. In here both for normal condition and acidic conditions have been studied for the high temperature vulcanized rubber and also the silicon rubber that is the liquid silicon rubber. So, this type of phenomena was noticed wherein lot of erosion and the puncture of the samples were also been done. So, further again surface morphological studies have been conducted using the scanning electron microscopy, EDAX and profilometer to measure the depth of the sample penetration, that is the damage of the depth using the profilometer wherein we could measure to what depth the damage has happened. So, some of these are very important in interpreting the information or the experimentations which are conducted in the laboratory. Observations from the inclined plane testings as per the laboratory studies both for AC and DC have given us some important results wherein the investigated samples using the inclined plane method for the high temperature vulcanized liquid silicon rubber both for acidic and normal contaminants show that and we have used for DC the AC RMS equivalent voltage which is found to be severe particularly for HTV and also for LSR samples, where we have seen that LSR samples are more severely affected in comparison to the high temperature vulcanized rubber. So, electrodes used for study also were degraded under the DC stress, and electrode material traces were observed over the surface which were observed in IDAX analysis. So, application of acid rain apart from the normal contaminant. So, acid rain contaminant has adversely affected the samples and causes more damages under acidic environment, and it was more severe in case of liquid silicon rubber samples. So, this is again confirmed by the leakage currents which has been measured during the experimentation, and the material degradation also was shown by the scanning electron microscope and the IDAX analysis. So, chemically the material degradation was confirmed by the Fourier transform infrared analysis. So, all these support the degradation of the experimentation conducted for both AC and DC applications. The importance of the aging or studies on the composite insulation is very important. As mentioned, there are methods for the aging studies as per the standards which are prescribed. Here you have the arrangement of a tracking wheel or the rotating wheel type of arrangement, which is depicted here as per the standard. You have a solution here in the tank. This solution is a salt water with a known quantity as per the standards. So, this phase where the insulator dips in the solution is known as the dipping phase. Further to dipping, the insulator travels here with the contaminants and halts at the horizontal level. So, this phase is known as the drip phase, where the contaminants drop. This stays for some period of time, then again it goes here, comes to the vertical position and gets connected with the high voltage. So, after the high voltage again which is known as the energized period, it comes back to the cooling period. So, this cycle where it starts from here, it will rest here for 40 seconds is the dipping period, 8 seconds is the transition, then again 40 seconds is the drip period, 8 seconds is the transition, 40 seconds is the energized period for the insulator, 8 seconds is the transition, and again 40 seconds is the cooling period. So, in total the total one cycle of rotation is 192 seconds. So, 192 seconds corresponds to one cycle. So, such cycles are conducted for more than 1000 hours. So, this could be 30,000 or more cycles which have to be conducted. So, this sample undergoes continuously for 43 days or 1000 hours plus experimentation. During the process, we have also tried to see that the contact or energized period, we have tried to measure the leakage current, whether the leakage current gives some information. This experimentation is a very tedious, particularly the aging experimentation, both the rotating wheel and the multi-stress arrangements. So, lot of effort is needed to fabricate and also conduct the experimentation. So, this represents the schematic as per the standard which is shown for the tracking wheel or rotating wheel arrangement. So, here is the study which has been conducted in the laboratory for as per the standards. So, for both AC and DC, the facility has been developed. You can see here we have an AC transformer, we have a rectifier unit. So, in case of AC, we directly use from the transformer bushing. In case of rectification, we use the diode rectification with the coupling capacitor which is giving a very less ripple, and this is applied here. So, the voltage is applied to this terminal here. You have a tank, you have both the tanks in fact here, which are designed intentionally for the normal contaminant and the other contaminant for acidic contaminant or so. So, we have a mechanism where the shaft is connected and simultaneously 8 samples can be connected. So, 4 of this arm and 4 of the other arm which are in contact with the tank. So, these insulators are connected for 40 seconds, it connect high voltage wherein it is energized, then other side it comes to the cooling for 40 seconds, then gets dipped in the solution for 40 seconds and dripping phase. So, this arrangement has to be made, and you have a white diaphragm wherein the sensor are being fixed here. So, these proximity sensors which are fixed will help in controlling the timing. We have a timer, we have a relay here which is connected to the motor and the shaft. So, this will control the timing as required. So, when the insulator comes in contact with the high voltage, you have from the arrangement wherein we have made a provision. So, this provision you can see here, the spring loaded mechanism here is here. This gets in contact with the insulator here, and you have a small shunt with the protective arrangements. Further, this arrangement is taken through the cable connection to the measuring oscilloscope or the measuring device where we can measure the leakage current. So, every cycle of the 40 seconds which the insulator gets connected with the supply, the leakage current flowing through the surface conditions is monitored over the period, over the 1000 hours period. This is an important information, electrical characteristics of the insulator, wherein helps in predicting the surface conditions of the sample or the degradation conditions of the samples. So, this we have tried to monitor for both AC and for DC conditions. Various samples, different types have been conducted the experimentation. You can see the process over a period of time. So, initially the scintillations or the arcs are very minimal or no arcs. Over the period of time you can see the small discharges, that is a partial arcs or the scintillations which happen. Either it could be randomly available near the high voltage end, in middle or at the ground end. This phenomena happens over a period of time depending upon the surface conditions and also the contaminants and the time. The arc starts bridging between the sheds. You can see between the sheds bridging of the arc is happening, sometimes bridging of 2 sheds or sometimes 3 sheds. So, this phenomena goes on as the period of time, and this increases for the voltage and the contaminants and also the surface conditions, wherein the samples after the 1000 hours has been observed. In some of the cases samples the flashover does not happen. In some of the cases you see the surface conditions, that is the roughness of the surface or the degradation of the surface has been noticed, in particular to the acidic conditions which is not standardized, wherein the surfaces have seen the puncture here, corrosion on the end fittings, drastic like damaging near the fiberglass rod. So, the entire shed getting damaged, changes in the color on the sample surface. So, several of this phenomena was noticed for both AC and DC conditions. Various types of changes, it could be the color indications, corrosion indications, failures, the puncture which has happened or the surface degradation at various levels has been noticed in the experimentation conducted for AC and DC applications for both normal contaminant as per the standard and also the acidic contaminants which are the data obtained from the acid rain conditions. So, here again several surface morphological studies have been conducted on the sample surfaces, and the composition or the surface conditions for various samples or contaminants have been noticed, and the results are interpreted for same Fourier transform infrared spectroscopy. So, you can see that lot of activity or the changes which have been shown here, the peak variations at wave number 1200, particularly at this here where silicon oxygen and silicon bondings, you can see that these bonds which imply the side chain of the PDM as a polydimethyl siloxane compound, changes which are happened, the peaks which are reducing gives an indication as mentioned earlier. wherein the depolymerization happens, and the CH3 groups which are responsible for the hydrophobicity if damaged by oxidation, and also results in the temporary loss of hydrophobicity can be noticed. So, here again the changes particularly at here and also at 1008 correspond to the breakage which could lead to the material degradation. So, this given information of how the samples could degrade over a period of time. So, the FTR analysis carried out at regular intervals will give you the indication of the surface changes which have happened. So, observations for both AC and DC in case of the rotating wheel arrangements, it is mentioned that especially designed and fabricated rotating wheel or a dip facility for both AC and DC studies is developed in the laboratory, which is a very difficult task and required lot of effort to make the arrangement work as per the standards, adjusting of the timers, adjusting of the sensors to the required level, and the performance of the experiment is a very important and effortful task. So, experiments were performed for both conditions as mentioned as per the standard or another normal specified contaminant conditions, and also the effect of acidic rain environmental conditions. This data was obtained from the literature, and the contaminants were simulated for the acidic rain. Then leakage currents as mentioned, a small leakage current arrangement has been developed, and the measurements monitored using a shunt resistance at the ground end, and the variation of leakage current data which is obtained is very significant to quantify and also to analyze and interpret, which gives an idea of the sample conditions was done. Then visual inspection of the sample before and after reveal that material degradation which is seen more in case of acidic treatment. This also was confirmed by the FTR analysis, where in acidic conditions the rubber sample or a silicon rubber composite material gets degraded early compared to the normal contaminants. So, care has to be looked, or importance has to be given for the composite insulators which could be used at that environment. The SEM scanning electron microscope and EDAX which are conducted, electron X-ray which has been conducted to find out the presence of different element on the surface of the insulators, and the TGA analysis which is thermogravimetric analysis shows increase in percentage weight loss for the acidic samples when compared to the normal contaminants. So, under acidic environmental treatment, accelerated corrosion particularly for the metal parts was observed, wherein the surface of end fittings confirm the presence of metal oxides with the analysis which is carried out. So, very important information which is a long duration experimentation which has been carried out. So, gives this information. The final is about the multiple stress arrangement. Multiple stress, this is again conducted as per the 6011 standard. Here we have to simulate several conditions, where again involves lot of effort here, wherein the chamber as per the standard shows the arrangement for various parametrics. You have to have a high voltage, you have to have the samples for salt arrangement, rain arrangement, UV arrangement, humidity, temperature, so on and so forth. So, again this requires lot of effort. This is being developed. So, in before that we have done the preliminary experimentation using the various multiple stress cycle. Here the standard mentions humidification, heating, rain, salt fog, solar radiation, voltage. So, you have 6 parameters here apart from the voltage stress, 5 parameters apart from the voltage stress. So, except for salt fog and rain, we have tried to simulate. A preliminary experimentation has been done, and this cycle is being developed in the laboratory. So, this is the preliminary experimentation which was mentioning. We have a chamber wherein we can have 4 insulators in service. So, this is the control arrangement wherein all the parameters temperature, humidity could be adjusted here, UV. You have a control panel for the voltage, it could be AC or DC. The transformer and the regulator is here, you are connecting it to the bushing, and the samples are inside the chamber wherein the facility for UV, humidity, temperature is available. So, voltage of known either AC or DC is impinged, and here the samples are stressed for 1000 hours or more, and during the process the cycle is developed wherein this particular cycle, this is with the UV, this is with the thermal imaging camera. The performance of the samples shows the red indication that equally samples are stressed for that particular temperature. The cycle which is developed, as mentioned, 4 parameters consideration. We have a high voltage, you have UV of 1 watt per meter square, temperature, humidity is been done, and various hours on 24 hours in a day has been fixed, and these 4 cycles, 4 stresses have been followed in a cyclic way, in service and out service. In service indicates the black portion, blocked portion, and the out service indicates the unblocked portion here. So, this cycle was followed for 1000 hours wherein the experimentation was conducted for various insulator samples and the slabs, and this experimentation again gives the aging performance over a period of time. So, several methods again like sample morphological changes which could happen have also been carried out here. This is one of the typical leakage current for a full scale insulator, where we have tried to measure the leakage current. This is the FFT of the leakage current, where you can see at a particular frequencies of the components present in the leakage current. The leakage current is measured over a period of time. This represents for a 500 hours, we have tried to measure for 1000 hours, and the leakage current pattern was seen, wherein increase from lower value to the higher value was noticed. Here initially experimentation were carried out from various conditions like temperature, humidity, UV and electric stress. Again the experimentations were further looked into for the lower temperature conditions also. So, for this a unique climatic aging experimental facility was fabricated to evaluate long term reliability of silicon rubber insulators under environmental stresses. It was noticed as experiment proceeds, a surface of insulators were degraded, and the dry band discharge starts in the presence of moisture in the humidity conditions, which is reflected in the measured leakage currents. FTIR analysis illustrated that surface hydroxylation phenomena on aged insulators due to applied humidification was noticed. Salt deposition was observed on aged samples. This was due to the multi-stress weathering. Many elementals like calcium, chlorine, magnesium, zinc, sodium are detected in the salt layer using the EDAX analysis. There was observed a shift in the TGA curve of aged sample with respect to the fresh. This is due to the mass of the salt deposition on the sample. Apart from this, tensile strength measurements on the rubber indicated reduction in breakpoint extension of the samples. This could be the aging of samples which show brittle nature due to the effect of UV which is applied. So, these observations were carried out for the higher temperature at 50 to 60 degrees and also at very low temperature at 0 degrees. So, lot of experiments were carried out, and the conditions or the surface conditions were monitored in the preliminary experimentation. So, with that we will stop, and we will discuss about the coatings for the protective overhead components which are used for both the network equipments which are used in electrical power systems.